So this video is going to be over 8-1 and 8-2, the homework. I'll do 8-3 and 8-4 in a separate video. The first one says use the figure for problems 1 through 4. So this figure right here is for the first 4 problems, and it's annoying because each one of these things is different. So you only get one diagram to label stuff on. So what I've done is I've drawn out 4 different versions of that diagram, and we're going to label them each. So we'll start out with the first one right here and go off what it says. It says that line P, this line right here, is the perpendicular bisector of XZ. So if it's a perpendicular bisector, it means it hits it at 90, which they gave us. And it's a perpendicular bisector, so it XY, and it's 15.5. And they want us to know, find out what ZY is. So they want us to find out what the measure of this segment is. Well, we have 2 congruent sides here. We have a shared side that's congruent to itself between the 2 triangles. And we also have another 90-degree angle here that's congruent to this guy, because this is a linear pair because they're on a line, so they have to add up to 180. So if that's 90, that has to be 90. So now I have a collection of 2 sides that are congruent. I'll highlight those in a darker blue. So 2 sides that are shared, 2 angles that are shared, those 90s, and then side angle side over here, 2 sides. So by side angle side, these 2 triangles are congruent, which means their parts are congruent. So if this is congruent to that, and we know this side's congruent to itself, then these 2 sides must be congruent to each other. So if this one's 15.5, ZY is 15.5. So ZY is going to be 15.5. That's the first one. Looking at the second one, this guy right here, given that XZ is 38, so let's write that down, XZ 38. So that's this whole segment right here. I'll do that in orange. This whole thing, I'll kind of do it off to the side, is 38. They give us that YZ, I'm sorry, YX is 27, and they give us YZ over here is also 27. Find ZW, so we want to find from here to here. So, again, we know that these angles match because they're a linear pair, so they are congruent. And we know that we have shared sides here, so these are congruent to themselves. We also know from the information they gave us that this side is congruent to this side. We have angle side side, which you know is not one of our theorems, right? But it does make us raise up the red flag and think, can I use HL, hypotenuse leg? And I can, because I do have a hypotenuse right here across from the 90-degree angle. Those sides are congruent. My hypotenuses are congruent. So I have 2 H's that are congruent, this side and this side. The sides opposite the 90 degree. And I have 2 legs that are congruent, leg and leg, the 2 right here, the shared side. So I do have enough to prove that these triangles are congruent. And if they are, I know that the parts are congruent. So this hypotenuse is congruent, these 2 legs are congruent. Last but not least, we must know that these sides are also congruent to each other. Well, if they're congruent to each other, then they should be half of the total length. So half of 38 is 19. So ZW from here to here is going to be 19. Moving on, let me fold this over. Those out of the way. All right, so looking at 3, given that line P is the perpendicular bisector of XZ, so they give us what they gave us in the first one. P is the perpendicular bisector, so it cuts this in half and hits it at a 90 degree. XY is 4N, so XY here is 4N, and they tell us that YZ is 14. And they want us to find what N is. Well, just like before, we know that this shared side is congruent to itself. So by side, angle, side, the triangles are congruent. Well, if the triangles are congruent, their parts are congruent, which means that this segment over here is congruent to this segment here. So 4N equals 14. So we want to solve for N. The way to do that is divide by 4 to both sides to break up the 4 in the N. and we get n all on its own equals whatever 14 divided by 4 is. Well, we can reduce that fraction, and it's 7/2. And that's as reduced as it can get. So n is 7/2. Moving on to our last one with this triangle setup, number 4. Given that xy equals zy, so we know that they're congruent if their lengths are the same. So xy is the same as zy, okay? wx is 6x minus 1. Well, wx is up here. So let's label that 6x minus 1. That's this whole side here. And we know that xz, this whole thing, this whole segment right here, is 10x plus 16. Okay, so that looks awful. Find ZW. We want to find ZW, this piece right here. Well, we know by angle addition, or the segment addition postulate, that 2 little segments make up the big one. So if we want to find one of the little segments, we can set them up in an equation and then subtract them to find the big one. So what I mean by that is this. If I take the whole segment, 10x plus 16, and again we wrap it in parentheses because it's an idea, it is the whole segment, and we subtract from it the little segment, right here in blue, we'll get this segment down here, the orange segment that we need to figure out. So I'm going to subtract the blue segment. The blue segment is 6x minus 1. And again, it's important to use parentheses here. That negative is going to distribute. So we have an idea minus another idea. Here are the parts of the idea. We always put those in parentheses for safety. So when we do math, we get 10x minus 6x, and that's going to be 4x. Remember that negative distributed in there? So we have a negative 6x. Then we have 16 plus 1, because a negative 1 is positive, so it's plus 1, and that gets us plus 17. So that orange section is this. Not a nice number, but an expression in terms of x. So the answer for zy, or I'm sorry, no, zw, is 4x plus 17. All right, so that ends it with that diagram. Now we're on to this next one, which we can use for both 5 and 6. All right, so 5 and 6 say this. Use the figure for problems 5 through 6. This figure right here, they say that SV. Let's use pink. SV, TV, and UV are all perpendicular bisectors of the side PQR. So let's make sure that's labeled on our graph or our diagram. Perpendicular, yes, they all have the 90 degree there. Bisector means that they cut those sides in half. So each of these sides is cut into their own halves. Again, I'm not saying that all the sides are congruent. I'm saying that the 2 pieces of each side are congruent to themselves. Then it says find each length. So RV is what we want to find. Let me highlight that. I'll do that in green. RV. Okay, so we want to find that length right there in orange. That's what we want to find. So, using this information, I know that all of these pink ones are perpendicular bisectors, and where they intersect right here at point V is going to be the circumcenter. And the circumcenter is the center of a circle that circumscribes the triangle. So if I were to draw this, it takes all of the vertices of our triangle and puts them on the same circle as best I can. And the center of that circle is right there. So that means any point from the center out to that circle, or that vertice, is going to be a radius. And everybody knows that the radius of a circle is equal no matter which direction you go in. No matter what line I draw from the middle out to the edge of the circle, it's going to be the same length. So I know that PV is 26. And it's a radius, and so is RV. So they're going to be the same length. So if PV is 26, RV is 26. TR. So TR is this segment down here. I'll do that in a purple color. TR. All right, so TR is this segment down here. And notice that because the pink line right here, this pink segment, VT, is a perpendicular bisector, we knew that this and this are going to be the same length because this whole segment is bisected into 2 pieces. So if this is 24, TR is going to be 24. Now let's take a look at 7 and 8. So 7 and 8 requires us to do some graphing, so I'm going to use some graph paper and make a little chart of those points. So here's my coordinate plane, and they want us to plot these points, so I'm going to write those down at the top. 0, 0 is A, B is 0, 5, and C is 5, 0. So I'm going to plot those points. 0, 0 is A. 0, 5 is B. So 1, 2, oops, sorry, let's do this. 0, 5. 1, 2, 3, 4, 5. That's B. There's A. And C is 5, 0. 1, 2, 3, 4, 5. So this is kind of nice. All of our points are on the axes. And so if I take those points and construct a triangle with them, I get this. My pink triangle, ABC. All right, so it says it wants us to find the circumcenter of the triangle with these vertices. Remember, the circumcenter is at the intersection of the perpendicular bisectors. So perpendicular means 90 degrees, and bisector means cut that segment in half. So if I want to find the perpendicular bisectors, I need to look at the segments and find their midpoints first. So I can eyeball the midpoint here. This is length 5 because it's from 0 to 5. So 2.5 should be the midpoint. That's cool. If I want to draw the perpendicular bisector to this side, I found where it bisects it. It cuts it into 2 equal spots. And then I can draw a line straight up because this is a horizontal line and perpendicular means vertical from there. So there's the first perpendicular bisector. Now I'm going to go to this side and find the perpendicular bisector here. You could find it on here, but this length you have to actually do a little bit of work to find. Remember, you only need to find where the first 2 intersect to find the circumcenter, because where the first 2 intersect is where the third one's going to intersect as well anyway. And I'll show you what I mean by that in a second. So this right here, again, we can eyeball the midpoint. It's at 2.5. It's the middle of 0 and 5. So this is the midpoint for that perpendicular bisector. And if we go from a vertical angle, 90 degrees from there is a horizontal angle. That'll be 90 as well. So there's our other perpendicular bisector. And as you can tell, they intersect at this point right here. Now, the midpoint for this side was at 5 halves, or 2.5, comma 0. And the midpoint for this side was at 0, 5 halves as well, or 2.5. So the intersection of those points, well, from here to here is 5 halves. So this point is over 5 halves in the x direction. So his coordinate is 5 halves, comma. And how far he is up is also 5 halves. He's 5 halves above, the same distance as this. So his coordinate is 5 halves, comma 5 halves. And that's the circumcenter for this triangle. Remember, the circumcenter is at the intersection of the perpendicular bisectors. If I was to find the perpendicular bisector for this side, you'd find out that the middle is right here, and that the perpendicular bisector goes at a 90-degree angle from this side. And notice, where it starts is actually where it intersects the other two. We didn't need it to find the circumcenter. Last thing I'll do, just for fun, is since that's a circumcenter, there should be a circle that hits all of these points centered at that point. So our perpendicular, or our circumcenter for number 7 was 5 halves, comma 5 halves. That's kind of an easy one because you can eyeball it. What's nice is that these are vertical and horizontal lines, and it's easy to find perpendicular bisectors to those. Let's look at the next one, which isn't as nice and requires a little bit of thinking. So we go with rate. It gives us these points. D is 0, 7. E is minus 3, 1. And F is 3, 1. So let's graph those points. I do need some negative space over here this time. So I put those points down. 0, 7 is 1, 2, 3, 4, 5, 6, 7. That's point D. E is negative 3, 1. So there's E. And I'll write those so we can see them. And then I've got 3, 1 for F. If I connect those up nicely, I've got my triangle DEF. Cool, so we need to find the circumcenter. Well, always choose the easy side first. These two sides are not vertical or horizontal. but this one is horizontal. So I can find the midpoint here pretty easily. That's 3 here and 3 there, so the midpoint must be in the middle. So the midpoint there is at 0, 1. And a perpendicular from there would be, since it's starting out flat, perpendicular would be a vertical line going up, 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 up along this axis. So there's our first perpendicular bisector. Again, perpendicular because it hits it at 90 degrees and cuts it in two, meaning it's a bisector. Now we have to choose either side, doesn't matter which one. I'm going to choose this side here and try to find the perpendicular bisector. So first I need to find the midpoint. Well, to find the midpoint is a little tricky for this. We need to use midpoint formula. And remember, midpoint formula is just, I'll write it up here, m equals the average of the x's, the average of the y's. And I'll show you the rest of that in a second. So the average of the x's over the average of the y's. Well, the x's here are 0 and 3. So that's 0 plus 3, which is 3. And then divided by 2 is 3 halves. The average of the y's is 8 divided by 2. 8 is what we get when we add the y's up, and then we divide by 2 and we get 4. So 3 halves comma 4 is our midpoint here. 1, 2, 3 halves, and then 1, 2, 3, 4. So right here on our line-ish, again my line wasn't drawn perfectly, is our midpoint for this side at 3 halves comma 4. Now before we could just draw a perpendicular really quickly because we had a horizontal, and horizontals have vertical perpendiculars. And for the other one we had a vertical, and we could just draw a horizontal perpendicular. This one is not horizontal or vertical, it's askew. So what we need to do is we need to find the perpendicular slope to this line in order to create a perpendicular line using that slope, to find exactly what angle we're heading off of here to make sure we're going off at the perfect angle. Because if we change our angle just slightly, it'll intersect this guy at a different spot. So we need to find the slope between D and F. So we need to know slope formula. Well, slope formula is very similar to midpoint. Midpoint is big M. Slope formula is little m, from like y equals mx plus b. The formula is, instead of adding the y's, we're going to subtract the y's. Because we're asking how far did we go up vertically? What was our rise, right? And how far did we go horizontally? Our run. Remember, distance is subtraction, so that's why we're subtracting here. And it's rise over, division bar, the run. So y2 minus y1. Let's call all of these guys coordinate 2, and let's call this coordinate 1. So the second one minus the first one. 7 minus 1 is 6. Excuse me. And we do the second minus the first here. 0 minus 3. Negative 3. So the slope between those 2 points is 6 divided by negative 3, which is negative 2. And that's the slope of this segment right here. So that's that segment slope. We want a slope that's perpendicular to that. Complete opposite. So what we're going to do is we're going to take that slope and we're going to flip it upside down and negate it. So when we do that, negative 2, when it gets flipped and negated, well, when we flip 2, it becomes a half because it's really 2 over 1 here. And when we negate it, that negative becomes a positive. So our perpendicular slope is a half. So we can use that a half for our slope to go from our midpoint up 1 over 2, up 1 over 2, up 1 over 2, and create a line. And if you have a straight edge, you can kind of eyeball where they intersect. This one's not going to work so well. Let me use a stapler. We're actually going to calculate where they intersect in a second. So there's our perpendicular bisector, and it intersects around here. Looks about right there. Looks to be about 0, 3. But the way to check it for sure is to find the equation of this perpendicular bisector and to find the equation of this line right here. So the equation of our perpendicular bisector in slope-intercept form is y equals 1/2, because we're using this perpendicular slope, x. And the y-intercept we're not really sure about. We need to find that. We do know that the midpoint is on the line, so 3 halves and 4 is a solution. So what I mean by that is if we plug in 3 halves and 4 for x and y, we should be able to find what the b value, the y-intercept is of m. So if I plug that in, plugging in 4 for y and 3 halves for x, I can solve for what my y-intercept is. Oops. So a half times 3/2, well, that's just 3/4. And if we subtract that from 4, we get 3 1/4, also known as 13/4. So 13/4 is what b is. So y equals a half x plus 13 over 4. So that's the perpendicular line equation. Now let's find the equation for df. Remember, df, we already found the slope. It was -2. So our df equation is going to be y equals -2x plus b. And we know on this line segment right here, we have 2 points. We have 0, 7 and 3, 1. Either of those will work. I'm going to choose 0, 7. If I plug in 0 and 7, 7 for y, 0 for x. This goes away, and I get 7 equals b, because -2 times 0 is 0, and b is left over. So the equation was really y equals -2x plus 7. So we have our df equation of this line, and we have our perpendicular bisector equation, half x plus 13/4. And we're going to set those equal to each other to figure out where they intersect. So where... Oh, I just did this all wrong.